Sent out a reminder yesterday afternoon about health sessions. So I'll have a health session this afternoon. Tomorrow morning, 7:15, and then also tomorrow afternoon at 3:30. So your test is going to be on Thursday. I'm doing a health session for my AB students on Thursday morning, so that's why I'm not having a health session for you guys Thursday morning, but I will do a health session with you tomorrow morning to go over to work through the morning review. So direction says find d2y over dx2. So you're going to find the second derivative. So find y prime first, and then work towards finding y double. Real quick, I want to make sure that that when exponents are involved, that we know what rule that we need to use. Because I see some of us maybe get a little confused in terms of like what category does the function fall under. So if I have y equals x squared, so if I have a variable raised to a constant, that's power rule. Right? I can just do power rule here. Y prime is equal to 2x. But if I have a constant raised to a variable, then this falls into the category of exponential. In this case, this looks a lot like e to the u, but we know the derivative for a to the u is natural log of a times a to the u times u prime. So the derivative of this would be natural log of 2 times 2 to the x times 1. But if I have x to the x squared, if I have a variable raised to a variable, then what's our strategy there? Yeah, this is log differentiation. So this is where we take the natural log of both sides. Bring that exponent down as part of expansion. And then we do implicit on the left, and then we do product rule on the right, and then we solve for dy dx.
You still do chain rule?
Still do chain rule. No, because we don't have a rule that can handle this particular issue, right? So we're forced into log differentiation. So this becomes 1 over y dy dx. We go through all the product rule, we bring the y back over, and then we bring the original variable back in. So I want to make sure that we are understanding that we distinguish between each of these different types and we can identify what category we're in, then we're taking the correct first step. Right? Because sometimes we may mistake one for the other and then it just throws us off. So I won't do that differentiation. I'll only do it at the variable based variable. I'll jump directly to the rule for you. So only do log differentiation at the variable based variable. Otherwise, it's just gonna make things more complicated on there. All right. Get right back. If you have any questions, if you're stuck on anything. Any questions with page 3? I do want us to have some time, just have some time in class to practice all the derivative rules that you're responsible for. So we learned all the derivative rules. We just have to work towards memorizing them. On page 45 and 46 in your packets, I have one template page and one page where all the key is. I printed out another copy of the blank practice sheet. Now, I won't give you a blank practice sheet on the test. This is just a way for us to kind of work towards memorizing the rules. Keep working, but then in a few minutes, I will kind of go through the rules, and then we'll spend like the last 10 minutes or so. I'll give you a blank copy, and you guys try to remember what you can remember for rules, because it's still 2 days away from the test. I'm not going to pick it up. I just want us to kind of get into thinking about working towards memorizing these rules. Okay, so let me go through the rules, and then give you guys a few minutes to look through it, and then we'll try like around like a little bit after 10 to see if we can practice writing out all our rules. And if we forget some, it's okay because we'll try again tomorrow, and hopefully by Thursday you'll feel ready with all these rules. Power rule, we know, we go with that. And these are all adapted rules with chain rules. So instead of just X, now U times U prime. So we talked about how sine, tangent, secant, cosine, cotangent, cosecant. I like to line up my C functions together in alphabetical order because they all produce negative derivatives. Cosine and negative sine, they kind of look alike. They're just involving each other. Secant squared and negative cosecant squared U, they both have the same form. Secant U, tangent U, negative cosecant U, cotangent U also have the same form. Tangent and secant just involve each other. Cotangent and cosecant also involve each other, basically for their derivatives. Next up, natural log and log base A of U. These are very similar. They're both logs, so they both have U prime over U. But log base A of U has a coefficient conversion that has to be involved there, 1 over natural log of A. E to the U and A to the U has very similar rules. The original function times exponent's derivative, original function times exponent's derivative. There's also a conversion that has to occur, or it's natural log of A. And the way I remember is log base logs have a denominator presence in the derivative. So it reminds me the natural log of A goes in the denominator. Here, my none of the parts of the rules has a denominator portion, so that reminds me natural log of A goes up top. And then finally, the arc trig. These are the ones that look most complicated. But we know that we can just memorize these three, then these three are just negative versions of the ones across them. I talked about how the way I memorize it is I start off with all the numerators are the same. They're all just U prime. And they all have 1 and U squared in the denominator. Arctangent looks the simplest. It has 1 plus U squared. And then arcsecant is the most complicated. It's got the absolute value and it has U squared minus 1. And what helps me remember that it's U squared minus 1 and not 1 minus U squared is I know my U's are next to each other. And if I can figure out this pattern, I can make a slight adjustment and do the arc sign, which is 1 minus U squared. All right, so look over your rules and then in about 3 to 4 minutes, I'll time us to see how much we can do in like 3 minutes. I'm not going to pick anything up. I just want us to have that practice with these derivative rules. So we'll start in a few minutes. You guys just want to. All right, we'll start in 1 minute. Okay, let's start. Let's see how much we can do with just a blank page. Okay, all right, let's see how we did. It's also page 45 on in your packet as well. The key. Okay, no homework tonight. Tomorrow, we're going to start interpret derivatives and particle motion. Obviously, it's not going to be on your test, but we'll finish up those notes and we can maybe spend some time finishing up or going over review if we have time at the end. But health session this afternoon, tomorrow morning, and tomorrow afternoon. Even if you don't come to the health sessions, really encourage you guys to work through the morning review as a way of treat that as your mock test and see how well you do. And that should give you an indication how ready you are for your test. Okay, no calculator on the test. Make sure you know your derivative rules. All right, come get your phones.
Yep.
Yes.
I actually don't have smile around with me.
Yeah. So 18. I'll show you on the board. I'm sorry.
I don't, it's come on.
Yeah, sure.
On the
Yeah,
internet,
that's-
it said the quiz is at 9, but it's like right here. I think it's.
Yeah, I bet.
They have here.
You would just.
Yeah.
This is the thing about it's there.
Yeah.
Yeah, you know, I have other people starting to say club.
I don't really know, but.
So we don't have a table for inverse, but we have a table for geometry. So you know that this must be the y value of the original function. So my word has to bring up, so I got force factor. I haven't used that as. That's the inverse, yeah. Okay, so the one find the derivative of a. Yeah, we know that. Trying to find 10 multiply now we don't find inverse multiply. They must mean that 9 is.
The method there is using the 3 math.
So without even looking at anything else, I know I can still. So I don't have a table for inverse of H, so I do have a table for H.
Oh.
So H as verb. I'm looking for the y value. We have H of 3.
Great.
Now this is now that's the target. There's a 3 running here. It must be running. So if I can find H, then this number will be the data for
Yeah, but you're thinking.
You know why? You should.
So this
Number 5. Oh, she forgot. Look at the room. I almost stayed for like.
You can take picture.
I thought today was extended.
Oh, that's right. It's extended. Yeah, let's go back.
Wow.
Oh, these features.
Like JC.
You have like a logo or something, because of the bottom.
Yeah, there's something else.
Okay.
Well, you can probably like. Do something so that it's like every text.
Yeah, I do like think there's all.
Yeah, that's.